Hello, Dame and Mercier Solutions. Today we're going to take a look at archive data. I'm calling this Archive Data 101. We're going to run through why, how, media, how you'd implement an archive, and we'll cover sort of from a home user perspective right up to a full enterprise solution. Okay, let's jump into the whiteboard. Okay, so looking at the board, what we're actually going to cover today is what archive data is not, backup storage compared with an archive, what the differences are. We're going to look at the different types of data, whether it's static or inactive. Really, these are the only two types of data that you want to be archiving. We're going to look at the benefits of archiving. We're then going to cover the actual storage media for archiving, and then we're going to look at the ways to actually implement an archive. Okay. So, archive data is not. So, it's not a backup. It actually replaces the backup. So, key thing here is we are actually replacing backup. What do we mean by that? So backup, traditionally, you've got files sat on your server and they are backed up or they change throughout the daytime. And then you would have a backup process that picks up those files and takes them to another device. So in the event of a failure or a user error deleting the file, that file can be pulled back from the backup and restored to the server. With archive, what we're actually saying is the data's not changing, shouldn't be changing. So we're going to actually create multiple copies of this and store it in the archive for the life of that data. And ideally, we're going to prevent the user from changing that data in its original location. Therefore, we've actually managed the data, replacing the need to back it up. So archive data, so it's data that is, in fact, this is wrong, it's data that's finished with or inactive. So finished with or inactive. Again, not changing. Another big misconception with archive is that it's slow. Archive doesn't have to be slow. It can be actually faster than your primary storage. All we're doing in essence is saying this data is now managed for the life of that file, and we're going to place and store and manage that on this storage system. The speed of that archive is therefore dictated by the speed of the archive, device or method. So it's not slow. Okay, so let's have a quick look here. Let's move this over a bit. Backup storage compared to an archive. So a couple of the key differences. Data in the archive is accessed from the archive, whereas a backup is merely a copy of the data that's sitting on a different storage system. So that is one of the key differences. It's accessed from the archive. With both systems, you would ideally have offsite copies. Again, this comes down to type of medium and how it's being managed. With any data storage system, you need ideally 3 copies on 2 different technologies and one of those off-site, and it's the same for an archive. So both would have off-site copies. And again, files aren't restored with an archive, they are transparently accessed. So what do we mean by that? So files that are in an archive, they might be sat on a tape, optical or a cloud storage system. And when a user requests that archive file, the request is passed through to that storage device to go and get the file from that medium and pass it back to the user. And that could be transparent. So the primary storage system, which may be a very fast, expensive enterprise storage solution, appears to still have the file on it, when in fact, when a user gets that file that's not been accessed for a couple of years, it goes off to the cloud, pulls the file back and then passes it back through as if it's come from that storage device. So key thing with an archive tends to be transparent access. On the flip side of that, if you're a home user and you've got a hard disk on the shelf, that's your archive, it may be that the access is less transparent, that you'd go and get the hard disk off the shelf, plug it into your computer, pull the file back off of it. Okay, let's have a look. Okay, so move that back to there. Archive data. There's two types really, and that is basically static data or inactive data. So inactive data, basically just old files that aren't changing. Maybe somebody's left the company and all of their old documents now need to be kept, but nobody's going to be modifying them or changing them. Therefore they're inactive and don't need to be sat on a very expensive storage system. Therefore they can be actually managed and archived. The other type then is static data. So this might be documents that don't change. We'll actually look here in a second at types of static data. So again, the static data could be new data that we don't want to be changed. So let's have a look at some of the file types and it'll become clearer here as to what is static data. So one of probably the easier ones to explain would be something like medical, where you've got X-rays and MRI scanners generating images that would want to be kept for the lifetime of the patient, which could potentially be 100 years. So with that data, once the scanner's taken that image, you don't want to go and change that. You're not going to open that up and start manipulating it. You want the original data kept for 100 years. So that new file that's been created now, today, can be archived and managed for that 100 years. Videos or photos. So if you're a photographer or a wedding photographer or a videographer, you've gone out, you've filmed or recorded an event, you've come back, you've got your memory card with your data on, you bring that back in. Those files, again, you don't want to be deleted, destroyed, got rid of, or even changed. So again, they're ready to be archived. You're still going to be accessing them, editing them, producing the final product, but the storage of them, we know we need to keep those for 20, 100 years again. So again, we can manage those as part of a workflow to archive them from day one, rather than this concept of, oh, we'll fill the primary storage up, oh, we've run out of disk space, we now need an archive. The archive should start right at the very start of the process, and the files should be managed from the moment they're introduced to the storage. Genomics research data. So again, if you've been crunching lots of numbers, DNA sequencing, stuff like that, generating big data sets, the results of those sets, again, don't want to change. So again, we can manage that and store that in the same way. Again, legal documents, invoices, email, and voice recordings. All again, documents that aren't changing, or we don't want to change. So again, we can manage these and archive them. Okay, let's have a look at the benefits of archiving. So, protecting files with multiple copies. So we've brought these files back in. Let's take an X-ray for example. It's come in from the scanner, it's gone into a primary storage system. The archive software has picked that file up and said, right, we need to keep this on the high-speed storage system for the next 60 days, but we also need to place a copy into the cloud and a copy onto this tape system. And so within a matter of hours, that software has picked those files up and created a copy in its original place where it's being accessed and processed from. We've placed a copy into the cloud, and then we've placed a copy onto tape so that we've protected that data with multiple copies. Therefore, in the future when we need more space on the primary storage system, we can actually replace that file with a link to the archive file, and so instantly we gain space for new data. It doesn't become a chore 6 months down the line that we need to take data off or expand the primary storage, because all we're doing is going to say, well, that doesn't need to be on there, it's not been accessed for 2 months. Therefore we can say if someone needs it, it will come from the cloud, or if the cloud's down, we can get it back from the local tape library. So again, multiple copies managed from day one. Efficiency, better user access. So again, what we're aiming to do with the archive software is actually manage the storage system so that 90–95% of all of the requests are served from the high-speed storage system. That way, rather than having a storage system where only 30% of the data is being used and 70% sat idle, we're using nearly 100% of the effectiveness of that storage system because we're actually managing the data and archiving it. And by doing this, we get a cost to saving in both time and equipment. The other key thing with an archive is we want vendor neutral storage. What does this mean? If you've got to keep that X-ray for 100 years, in 20 years time, the company that makes the storage system today may not exist. But if the archive can actually be reattached to a different primary storage system, or the data is in such a format that can be attached, we're actually managing that data for 100 years by the storage in what we'd call a vendor neutral. So it's not proprietary. And by doing so, we get away from this concept of every 5 years of migrating from this set of tapes to this set of tapes to this storage system. We actually manage the data in situ from day one. And yes, we might migrate the data in 20 years or 10 years time, but we avoid this need to migrate from A to B. And particularly if you're using the cloud, migrating from one cloud to another cloud may not necessarily be the easiest thing to achieve. Again, if we've got multiple copies perhaps on a tape library, it could be in the future that the archive says, okay, we're going to attach cloud provider C, new one now, it's 5 years down the line, policies have changed, and we're going to restore all of the data to the new cloud from the tape library, and the archive software can manage that. We're still on the primary storage, we're using the same primary storage, accessing from the same archive, and transparently in the background the archive has moved the data to the new cloud. So vendor neutral storage, we're not tied in to any one particular system or solution. And that also goes for the primary storage. Once you've got the data managed in the archive, we could say, well actually we don't want to use this primary storage system. We've got a new one now, it's 20 times faster, more cost effective. We just need to restore all our data. And if we're archiving everything that's on there straight away, we could actually connect the new storage system to the new archive and have the archive say, restore everything. And it can create links to the archive. And then we can say to the archive, put every file that's less than 30 days old or has been accessed in the last 30 days back on the primary storage. And so within a matter of a couple of minutes, we can generate millions of files on that primary storage. And then over a period of a few days, depending on the storage technology behind the background and the actual requests for stuff that's already archived, we can transparently put all of the files onto the new system and actually manage that. So this vendor neutral storage system is a key strategy for managing those costs and actually managing that data. Next thing, storage medium. At the moment, we've got a lot of different options. Choosing the right medium or combination of the media that you actually use for the archive will really affect the usability, how you can retrieve files from it, and the cost of that long term. So, three main physical technologies, and then obviously cloud, whereby we'd be renting one of these or a combination of these technologies. So each of these storage mediums have different properties. Tape is obviously very low cost. The media can be stored off-site. It's good for creating a DR solution or a migration solution. So I think this will work well combined with something like a cloud storage system, or for very inactive data or very large files. Because obviously the transfer rate on tape is very fast. Okay, so tape is obviously a sequential media. What that means is, if you've got 20 terabytes of data sat on a tape, the first file that's written to it is at the start of the tape, and then there's a file at the other end of the tape. Getting the first file and the last file could take the tape drive 5 minutes to spool between one end of the tape to the other end of the tape. Obviously there's a limited number of cycles that tape can do this, so it's not designed for regular random access. This is really for infrequent access or for bulk restoration of the archive to another device. So in combination with disk or cloud, this solution works well. Disk. Well, this is hard disks, and again, this could even represent, as a home user, your USB disk that plugs into the computer you copy files to. And it might be part of your process. If you're that wedding photographer, you come back in, you put your memory card into the computer, you copy it to your primary storage, you also copy it to the USB hard disk. The USB hard disk gets ejected, taken out, put on the shelf and stored. And again, with disk, this could represent different types of storage technologies to manage it. Optical. Now this is a 40-year-old technology. It's often overlooked today. However, it does have a lot of advantages over both disk and tape, particularly for archiving. From a home user point of view, you can get Blu-ray discs. Sony make a quad layer 128GB Blu-ray disc, and providing you've got a modern drive that's got the firmware that can write to it, you can actually record 128GB onto a piece of medium that's about $10, £7 roughly in the UK. And that medium is then warm, so it cannot be changed. And this is really good as an alternative or a secondary copy, perhaps to go along with a hard disk, for archiving critical data, even as a home user or as a business. Now in an enterprise solution, we've got a couple of means. We've got a robotic library that can actually move these disks automatically and manage writing to 128GB media. And we've also got the Sony optical disc archive. Now this is a cartridge-based system. Again, the cartridges come in a case like this, a small cartridge about the size of a tape, and inside the cartridge there's 11 optical discs. The third generation of these discs now hold 5.5 terabytes on each cartridge. Sony rate these for 100 years. So again, it is specific media designed for archive. Again, this can be connected in a library, which can expand to petabytes of storage, or you can have a standalone drive that's USB that just plugs into your computer. Obviously this is significantly more expensive than the 128GB media and standalone drive, but you end up with one piece of media that holds terabytes of data versus 128 gigs, and the transfer speeds of these are faster than a hard disk. Lastly, cloud. So cloud, you can buy storage as a service, and that may well be technology such as S3 or file object storage. One key thing with the cloud, again particularly with S3, it's often overlooked, is the need to back it up and have multiple copies. Sending it just to one cloud service or one cloud data center is not enough. Recently there was a fire in a data center and it affected several of the buildings on that site, and several companies actually lost data where they were relying on the cloud to keep it safe. Okay, ways to implement an archive. So we've covered roughly some of the ideas and concepts on how we could archive. So manually, and that's probably the most common way that I come across, whether you're a home user or even a business, where a network administrator or a home user is literally saying, oh, my computer's full up. They're plugging in a device or another storage system and moving the data from there to there or copying it. So again, that's a manual storage solution. The next could be a dedicated archive storage system. So what would that might look like? Maybe a NAS or another server with a storage device attached to it. And again, we'd be moving the data to the archive, or possibly using some software to pick the data up from the primary storage and move it to there. Next level on would be transparently. So a lot of the enterprise systems and even some of the prosumer NASes have tiered storage solutions, whereby you can create an information lifecycle management policy. And there you can actually define that the data sits on this primary storage for a period of time, or a threshold, i.e. much space is left, and then places a copy onto the cloud or to another storage system that's attached to it. And that's built into some solutions. Often those solutions as an archive work great, however they tend to be tied into that particular product, so they're not vendor neutral. And again, if we need to keep this data for 100 years, managing it from the earliest opportunity is going to give you the best results long term, and avoid a problem 5-10 years down the time when your options to migrate this primary storage system to another solution is very much tied into that particular channel or brand because of the way that the archive or information lifecycle policy has been applied. So it makes sense to look at the exit strategy from that storage system and migration, what's involved in it in 10 years down the line. Often this is overlooked. Lastly, unstructured data. Now, this is what will happen if you give a user a folder. They will chuck data in there, and every user will store data in their files in a different way. So what you end up with is unstructured data. So as an administrator, you don't know what those files are, how important they are, when they're being accessed. Again, managing that unstructured data into an archive requires a piece of software to actually go through and identify inactive files and the file types. And based on the file types and when it was last accessed, policies can be applied as to how it's archived, stored and moved off the primary storage. Thank you for getting to the end of the video. If any of these concepts are interesting to you, or you would like to learn more about any particular subjects here on the archiving, perhaps how to as a home user archive with 128 gig media, or as an enterprise, how you would actually use a big optical system, don't forget to join the channel. We'll cover these topics elsewhere there in other videos. Again, if we can be helped to you, reach out to us and get in touch. Thank you.